Okay, this is the work solutions for the geometry part we've been doing. Remember, if you've had problems or questions, you need to go into the textbook that's been shared so that you can find suitable other questions. So most of these are supposed to be 30 minutes of questions. And let's start with question 1 then. It's asking about the volume of a cuboid. The thing to remember about a cuboid is it's a form of prism. And the volume of the prism is the area on the cross section multiplied by the length going backwards. So the area on the cross section is this piece. So A equals 20 times 20, which is 400. Hopefully you can all do that one in your head. And that's 400 centimeters times centimeters gives us centimeters squared. And then we need to do multiply by the length going backwards. So this is now my length at right angles to all of this direction. So the area gives us a set of directions. This is at right angles to it. If it's not right angles to it, you can't do that. So nearly every situation you come across, that's fine. So the volume is my 400 times 40. And it gives me my final solution. Notice this is 400 times 40. Again, sorry, I forgot to check, calculating the right mode, it's using decimals. I've got no funny setups. And this says 16,000 centimetres, and the units are cubed. Now, because this is a 3-mark question, I fully expect you to lose a mark if you haven't given the right units. So let's just have a quick check in the mark scheme. (16,000 centimetres cubed). Yeah, 1 mark for the calculation, 1 mark for the value, and then 1 mark for your units. This second stuff, what they've done here is they've done the calculation using meters. So they've converted everything to meters and said they're happy for you to give answers in meters cubed as well. But notice no units were given in the answer, so you should give units. Here's another cuboid. This time we've got to calculate the surface area. So if you remember, the surface area is built up of all the rectangles making this shape. Other shapes, they can be triangles, but it's the area that's needed to cover it. So what we've got are, if I call this one the front, it's got a partner on the side at the back. How big is the front? So we've got front and back. That gives us 6 times, and the height here, because it's a cuboid, this height is the same. Okay, so front and back, area of each of those is 1.5 times 6, which hopefully you can do in your head as 9. So the total for those two faces is 18. And if this is the front, we've got a left and a right. They are a pair for a cuboid. And they are both 1.5 times 1.5. Now you might struggle with this one a bit more, but it should be 2.25. Again, there are 2 of them, so we get a total of 4.5. centimeters squared. Last one is top and bottom. Left, right, so top and bottom. It's back. So top and bottom, again they're 6 by 1.5, same as the top, which is 9, which is 18, and we add all of this together, 36 plus 4.5 is 40.5. All the units came from centimetres times centimetres and then double it. That's a number, so it doesn't change it. So all of these are centimetres squared. And then fill this in. Again, I think you'll get a mark for the units as well. Let's have a look at the question. Volume calculation, no mark. So no volume calculations allowed. Correct answer, fine. method mark for showing how you calculated the area of the one marked face, and that you are doing 5 or 6 faces. The reason they're allowing 5 is they are allowing for some people who might think that the box is open. The diagram doesn't show it. They've not said it. It should be all 6 faces, especially when they say a cuboid. They didn't mention box at all. Right, prisms, volume of a prism. Again, so we're back to the V equals A times D. And calculating the area here is a little bit more difficult. There's a couple of ways of doing it. We're going to use this funny shape on the end, this L shape. 2 ways to go about doing that area. One is to split the box off at the top, and you've got to work out the missing sides, so that's 5. This is 4 on this end, that's 11. If this is 4, then this bit is 4, and that bit must be 3 to make it up to 7. And then you calculate the area of each, so that's 15, and that's 44, which gives me an area of 59 centimetres squared. Or you can split it down there, or you can even split into 3 shapes using all 3. There's even a technique, I'll show you that one as well, taking away as well. So you could split it down this way. We've still got 5, we've got 7 down the side, we've got 11 along the bottom, so that's 5 and 6. And we've got 4 up the side, so this is 24, this is 35, and that's 59 again. Third one is a takeaway method. And what we're going to do is we've got 7 times 11. This is the full area. So that's 77, and we're going to take off this block here, which we now know is 3, and this distance here must be 6. 5, that's 4. 3 6s are 18. 18 from there. 20 would be 57, so that one is 59 again. So we got in a third way as well. Squared, I don't know why that cubed up here. So the volume of this is that 59 centimetres squared, multiplied by the length going back. Quick check, because the answer's in centimetres, just realised I should have checked everything was in centimetres to start with, and the length going backwards is 20 centimetres. So my area now is 59 times 20, which is 1,180. 1,180 centimetres squared. Okay, question 4. This one's just more of a puzzle one to build out what's going on with this. How do we calculate the area? They said this is a square paving stone. So these 4 sides are all equal. And what they've told us is how long this side is. The way they've done it is they've told us this is 60 centimetres 3 times. So that length there is 180 centimetres. So that length, 180 centimetres, has been split into 4 squares. And that will tell me what 1 square is. Equivalent fractions, remember there's a 1 on the bottom. So 4 squares goes to 180 divided by 4 is 45. So we get 45 centimetres. First mark is for finding that 180. Each point was 6 by 3, 120 wide. How many does she need? Right, so it's how many 60s are needed along here. So 720, so the width is the 720 divided by 60. So this is the total number of blocks divided by 1. and that says that we're going to need divide by 60. 720 divided by 60 should be 12. There you go. And the length in terms of blocks is 120 by 30, which I hope you all realise is going to be 4. So there's 120 along the length, one length is 30, so one block on the bottom. My equivalent fraction thing still. Don't forget, this is all talking about equivalent fractions, even if we're doing these calculations. So one block on the bottom is going to be 120 divided by 3, which is 4. Equivalent fractions going on. So we've got 12 by 4, so blocks. Because there's nothing left over, no chopping needed, we don't need to worry about is there any bits left over. It is just straight 4 by 12, and that's 48 blocks. Okay, into circles. Draw and label the following. Now this is a modification to the original question. The original question was calculate measure the diameter. Not knowing how big your printout's going to be, we can't put that question in. But if you're to measure a diameter, the diameter goes across a circle through its centre, and you must go through the centre when you measure. So that's my diameter. A radius is the distance from the centre out. So it doesn't matter where you put it, as long as it goes from the centre and it's a straight line. The circumference is all the way around. So as long as you're clear, it's going around the outside of the shape, you'd get the marks. Okay. Draw a sector. Now, a sector is the part of a circle between two radii. Okay. So half a circle is a sector. Next bit. What type of line is that? Well, if you think about loads of them going across, you start looking at a guitar and its whole, and if you string across all of them, it's a chord. Just as a little note, a chord breaks a circle into segments. So the bits either side of a chord are segments, and they're called minor, the small one, and major. A little side note. But sectors are between two radii. Segments split a circle across a chord. So here's a diagram not properly drawn. Here's a circle. The diameter is 9. Work out the circumference of this circle. Now, there's not a question in here, I don't think. Oh, yes, there is. That's all right. We can do it. So circumference, if you remember the song, pi r squared sounds like area to me. If I don't know them off the top, I'm going to make a quick note. If I want the circumference, I use pi d. Now I've been given the diameter, so that's okay. That's my equation. But if I've been given the radius, I need to remember also that the diameter is 2 radii. If you're not sure, or you're trying to remember which equation applies, write them down. Look at them. If you can see it on your paper, you're using different parts of your brain. So one of the biggest mistakes people work on is they keep things in their head and they keep hoping that they can get the right answer. So I've been asked for the circumference. C equals pi times 9. Use a calculator. Pi is normally on these bottom buttons, but because it's not the button itself, you do shift to get the thing above it, and multiply by 9. Now if you want to check if you press the right thing, press equals and you should see a number 3.14159. If you see 3.14, you know you've got pi. So I'm going to multiply that by 9, and it gives me an answer 28.27433 and some more digits. And the important part on this answer is the second mark is going to come from doing this piece. the three significant figures. Three significant figures means start at the start of the number where it's not 0 and count 3 places. 1, 2, 3. That last place, check the digit next to it, just that one. You ignore all the others. And then you decide, does it round up or round down? If it's a 5 or more, round up. If it's 4 or less, round down. It doesn't matter what comes after that. It's purely that number. 7 says round up, so we now get 28 point, and the 2 now rounds up to 3 centimetres. So, we've got a conference table. Sophia's organising a conference. They will use circular tables. Each table has a diameter of 140 centimetre. Each person needs 60 centimetres around the circumference. There are 12 of these tables, and she has 90 people in the conference room. Are there enough tables? Now, first thing I would look at is how many people per table. That gives us, using the diameter part, so people per table. We need the circumference, and each person needs 60 centimetres. So if we get the circumference, C equals pi d, missed off the area question, so we need to work out. In a minute we'll do a quick question about, and I'll ask you, how big is the area on the top of this table? So remember the song, pi r squared, sounds like area to me. If I need the circumference, I use pi d. And also remember that diameter is 2 times the radius. There are little notes. So C in this case is 3 times 140, which is going to be 420. Oh, about 3. Pi times 140. Cancel. Cool. Pi times 140. That gives me 439.8 centimetres. Fairly certain I don't need to be more accurate than that, but I'm going to store it in my memory in case. So shift, store into a memory, and that's the circumference, so I'm going to put it in memory C. So I can remember, I'm going to put a little note, it's in memory C. So how many people per table? Is that answer. Divide by 60. That says 7 people can get round a table. 7.3, but that 0.3 of a person has nowhere to write. So there's only 7 people able to get round, and there's a bit of spare space. And this bit is way too small for someone to sit in. So we've got 7 people around the table. So we're talking about people, we can't have half a person at a table. Okay, so there's 12 of these tables, so the total people we can sit is 7 times 12, which is not enough. We need another table. And don't forget, we need to state, answer the question, are there enough tables in the conference room? If you say 84 people, you may only get 3 marks. So, no. And you can even say, we need another table. Wouldn't get you any extra marks, but it really does show your understanding. One benefit of that is it puts the examiner in a slightly happier mood. You've shown that you can do something. Okay, we're now into right angle triangle. As soon as you see a right angle triangle, you think either gradients or Pythagoras. We want to calculate the length of xz. xz is here. So yeah, length, so we're going to use Pythag. Or I'll come back and do the area in a minute. So Pythagoras, we need to calculate the length here. Check where the right angle is. So this right angle says this side is the hypotenuse, and the other two sides don't matter. If you need to remember it, Pythagoras is hypotenuse. The square on the hypotenuse is equal to the sum of the squares on the other two sides. I prefer using H to C, but if you use C, it's not wrong. But H is a special side, so I don't like it being in order with A and B. So put our values into our formula. So this is where my first mark comes from. I don't know what H is, so I'm going to use their value xz squared, and that is equal to my A squared, 1.35 plus 3.25, and that will give me the distance squared. So 1.35 squared plus 3.25 squared, and it gives me the answer 12.385. To get xz, I want to take the square root. So I do the square root of xz squared, it gives me xz, and whatever my answer was, square root it. And that gives me an answer 3.519232871. Again, last mark, 3 significant figures. Start at the first value. That's not 0. 1, 2, 3. What does the next place say? 9 goes up, and ignore all the other digits. So we get 3.5. 1 rounds up to 2. Units are meters. Probably wouldn't, you might get 1 mark for meters and 3 significant figures, but it being either. Okay, so now into this last one where we've got to do the trapezium. We want to find the length of AC. So that's this diagonal length here. Now to get that length, I need to know what BC is. And BC is the same as a length across here. So I'm going to give a point X, and XD equals BC. And if I look at these and they're parallel, I know that this is this right angle. On this side I've got 3, and on that side I've got 6. So I've now got a triangle at the top, which is my hypotenuse, my side A and my side B. And B is the one I'm trying to work out. So H squared equals A squared plus B squared. Put it in a thought bubble because I won't get any marks for that. If you're going to use a little b, notice that's 6. If you're going to use little a and little b, do make sure they're on the diagram somewhere. So H squared is 10 squared equals A squared is 6 squared plus B squared squared. So B squared equals 10 squared minus 6 squared. Some of you may jump to that number already. I'll tell you in a minute some numbers that we'll look for and why I might have not needed to do the full calculation. Put the numbers in. So 10 squared minus 6 squared, because we've taken the 6 to the other side. That's 64. So my B is the square root of 64, which is 8 centimetres. Now, I knew that quite early on, because what we've actually got at the top there is we've got 6 and 10. And if they're a Pythagoras triangle, that's a 3 times 2, that's 5 times 2. The other side is 4 times 2. A 3, 4, 5 triangle is a standard one, and if it's going to use whole numbers, that's where you'll find it will come in quite a lot. So we now know B, which means we now know BC. Because we know BC, we can now do Pythagoras to find the length AC. AC is my hypotenuse, so AC squared is equal to AB, which is 9, plus BC, which is 8. So AC is 9 squared plus 8 squared, 145. The length AC, I'm going to do the square root of both sides. So I square root that 145. And that gives me 12.04159. Again, 3 significant figures. Start at the top for the most significant number, 1, 2, 3 places. Look at the 4, it rounds down this time. Rounding down says leave it as it was. It's 12.0 centimetres. Check your units on the end. So just one last thing I wanted to quickly go through. What's the area at the if you're asked how big is the area at the top of this, you would have to do half of the 70 to turn it into half of the 140 to turn it into 70. So the area of this area of the table is going to be R, it's 140 over 2, which is 70. So the area is pi r squared, sounds like area to me. And that gives me 393.804 centimetres squared, which, if I round it to 3 significant figures again, is 1, 5, first 3 digits. This says round up, and then the number must be the right size. So you can't just ignore the fact that this is 2 places on, you just fill them in with zeros. That's why I wanted to come back and do the area part of that question. Well, add an area part to the question.